Hi, welcome to my video on the type and the number of equal and unequal roots, part 1. A quadratic. In a quadratic equation, which is x equals negative b plus or minus square root of b squared minus 4ac all over 2a, the discriminant is b squared minus 4ac is under the square root. The discriminant is under the square root. Hence, the value of the discriminant determines if the roots are real or imaginary, and it determines the number of equal or unequal roots. And in this video, I'm going to demonstrate what I'm talking about, real and imaginary roots and the number of equal and unequal roots, looking at the discriminant, which is b squared minus 4ac. Let's solve these four equations first, and then we'll pick up the data belonging to that. So we're going to solve each of these. I'm going to use the quadratic formula to solve these to illustrate, because the quadratic formula has the discriminant b squared minus 4ac. So a is 1, b is 5, c is negative 6. So x equals negative b plus or minus b squared minus 4ac all over 2a. So b is 5, so that's a negative of the 5, plus or minus 5, b is 5, a is 1, and c is negative 6, all over 2 times a, and a is 1. And that simplifies to negative 5 plus or minus square root. Now let's work this out first so we don't have to write it down. Just fill in the number here. 5 squared is 25. And we multiply next to give us negative 4 times 1 times negative 6 is 24. And that's a 49. So let's put the 49 in there. And 2 times 1 is 2. And the square root of 49 is a 7. So we have negative 5 plus 7. Negative 5 plus 7 over 2. Or negative 5 minus 7 over 2. And that gives us 2 divided by 2 is 1. And a negative 12 divided by 2 is negative 6. I'm deriving these roots and enter the information on the next sheet. Let's solve by using the quadratic formula again. So a is 1, b is negative 4, c is 1. So x equals negative b plus or minus b squared minus 4ac all over 2a. This time b is negative 4, so it's the negative of a negative 4, plus or minus negative b is negative 4, a is 1, c is 1. So we enter that information, and a is 1, so it's 2 times a, 2 times 1. And the negative of a negative 4 is a plus 4, plus or minus, and let's work this one out now. So negative 4 squared is 16, and negative 4 times 1 is a negative 4. So that gives me a 12, and 2 times 1 is 2. The square root of 12 is a 4 times 3, so it's a 2 root 3 all over 2. So we can't add or subtract these, so we'll go 4 over 2 plus or minus 2 root 3 over 2. So 4 divided by 2 is 2. 2 divided by 2 is 1, so we get plus or minus root 3. So the two roots are 2 plus root 3, 2 minus root 3. And again, we're getting practice on solving by the quadratic formula, but I need this info to explain how the roots are real and imaginary, equal and unequal. So the quadratic formula, negative b plus or minus b squared minus 4ac all over 2a. And b is negative 10, so it's the negative of a negative 10, plus or minus. Negative 10 is b, a is 1, and c is 25. All over 2 times a is 1, 2 times 1. Negative of a negative 10 is 10, plus or minus. And a negative 10 squared is 100. Negative 4 times 1 times 25 is subtract 100, so that gives me a 0. All over 2 times 1 is 2. So that's 10 plus or minus 0 over 2. So we have 10 plus 0 over 2, or 10 minus 0 over 2. So that gives us 10 over 2, which is 5. And 10 minus 2 over 2, 10 minus 0 over 2 is also a 5. And notice the two roots are the same. I want to mention that because this is factorable. Notice that this number here, which is called the discriminant, is 49. That discriminant 49 is a perfect square, so this comes out to be a rational number of 7, so it's easy to add the roots up. And also right here, this discriminant is 0. So therefore, the roots are going to be rational. So that means that this trinomial can be factored as x and x. Factors of 25, which is a product to give me a 10, is 5 and 5. The product is positive, the sum is negative, so it's a negative 5, negative 5. So you can see that 5 and 5, there's 2 roots of 5. And that's the same up here. Because that discriminant is 49, which is a perfect square, that means that this trinomial is factorable. X and x gives you the x squared. Factors of 6 to give you 5 has to be 6 and 1. The product is negative, the sum is positive, so it's got to be a positive 6, negative 1. And you can see that the roots are negative 6 and plus 1, which is what I have. But because that discriminant is a perfect square, then this trinomial is factorable. And this trinomial is factorable because 0 is a perfect square. 0 times 0. Just want to mention that. And let's continue. A is 1, B is 2, C is 5. So x squared is x equals negative b plus or minus square root of b squared minus 4ac all over 2a. B is 2, so that's the negative of the 2, plus or minus 2 squared minus a is 1, c is 5, and 2 times a, 2a is 1. So the negative of the 2 is negative 2, plus or minus, and we want to work this out. That becomes 2 squared is a 4. Negative 4 times 1 times 5 is negative 20, so that gives me a negative 16. And the square root of negative 16, because it's negative, square root of 16 is 4. Because it's negative, it's an I divided by 2. We cannot add or subtract, so we'll go 2 over 2 plus or minus 4i over 2. So we get 1 plus or minus 2i. Again, we have imaginary. Notice we got a negative, so that means that the root is imaginary numbers. Okay, we have all the roots. Now, what I'm going to do is I'm going to transfer all this info that I have on these 4 to a page over here. So notice the roots here are 1 and negative 6. That's real roots. Notice I have 2 plus root 3, 2 minus root 3, that's real roots. Notice I have 5 and 5, they're real roots. But here I have imaginary roots because I have the I. I stands for imaginary. And notice they're not equal. Notice 2 plus root 3, 2 minus root 3, they're not equal. Notice here I have the 2 roots are equal, 5 and 5, and here the 2 roots are not equal, 1 plus 2i, 1 minus 2i. So I'm going to transfer that info to this page. Here we go. So in D, we had a root, D is determinant. We had discriminant, not determinant, discriminant of 49 that was underneath the root. And we had the roots were 1 and a -6. And those roots are real roots. And notice they're not equal, so they're unequal. And how many roots are there? There's 2 roots. Every quadratic has 2 roots. B, the discriminant was 12. The roots was 2 plus root 6, 2 plus root 3, and 2 minus root 3. And the roots are real, and they're still unequal. Notice they're unequal because they're not 2 plus root 3, 2 minus root 3, and there's 2 roots. And in C, the discriminant was 0, and the roots were 5 and 5, and they're real roots, but they're equal. And we have 2 of them, 5 and 5. And we found there's 2 of them because when we factored, we had an x minus 5 times x minus 5. And D, the discriminant, was a -16. And the roots were 1 plus 2i, and the other root was 1 minus 2i. And these roots are imaginary. Imaginary because you cannot do the square root of a negative number. And imaginary, again, notice the I. Imaginary. Imaginary begins with I, so we have an I. That's one way I think about it. And the roots are unequal. They're not the same. And there's 2 of them. So let's take this info and see what happens when we come up with. What about the value of the discriminant? There's the discriminant. The value of the discriminant is greater than 0. If the value of the discriminant is greater than 0 would be 49 and 12. So there's the discriminant of 49 and 12. That's greater than 0. So if we have the discriminant greater than 0, we will have real roots, but they will not be imaginary. And if the discriminant is greater than 0, like these two, both of them, no matter what they are, perfect square or not, the roots will be unequal. What about if the discriminant is 0, like this one? So if the discriminant is equal to 0, the roots will be real. Yep, they won't be imaginary, but the 2 roots will be 5 and 5, so they're equal. Then what about when the discriminant is less than 0? And that's a -16. So if the discriminant is -16, the roots will be imaginary. And they'll be unequal. And also another scenario sometimes, what about if they say the discriminant is greater than or equal to 0? So if the discriminant is greater than 0, the roots is real. If the discriminant is equal to 0, the roots are real. So if the discriminant is either greater than 0 or equal to, we have real roots. But if it could be equal and unequal. So it could be that or that. So if the discriminant is greater than 0, the roots are unequal. If the discriminant is equal to 0, the roots are equal. But the main thing is, if the discriminant is if the roots are real, it could be greater than or equal to 0. You'll see that in some of the applications I'm going to do later on. So in summary, the discriminant, D stands for discriminant. If the discriminant is greater than 0, discriminant is greater than 0, the roots are going to be real. And they're also going to be unequal. So if your discriminant is greater than 0, as a 1, a half, 5, 10, 20.4, the roots are going to be real and unequal. If the discriminant is equal to 0, then the roots are going to be real. If the discriminant is equal to 0, the roots are real. But they're going to be equal. Notice equal 0, equal roots. Greater than 0, unequal. Less than 0, we're going to have unequal. What about if your discriminant is less than 0? The roots are going to be imaginary. And they're going to be imaginary and unequal. So that's summarizing this info that I'm going through. But I solved 4 equations with the quadratic formula to show you about the discriminant and how the discriminant decides what type of roots you're going to have. Again, notice equal 0, equal roots. If it's not equal to 0, then the roots are unequal. Unequal. Less than 0 is not equal. Unequal. Greater than 0 is not equal. Unequal. The only time you have equal roots is when discriminant is equal to 0. And if discriminant is less than 0, that's a negative. You got imaginary. In the other 2 cases, we have real roots. So hope you enjoyed my video. I'm going to need this info. Very important. I will need this info when I move on to the next video. If you like my video, click the like button, the subscribe button, and the notification bell. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. And that's the content that's going to be on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.